So to finish up our discussion of magnetism and electromagnetism, I want to look at kind of an interesting phenomena or application, if you will, that's the result of eddy currents. So what we see sketched on the board is a copper pipe and a permanent ring magnet around that copper pipe. And we can see here, of course, the flux that is created or is present in and around this permanent magnet. Now, if I drop this magnet or let this magnet slide down around this copper pipe, then we're going to have relative motion between flux and a conductor. And again, whenever we have relative motion between a flux and a conductor, we will induce a voltage. And if there is a path or a closed loop, we'll have current. So what happens is, as this ring magnet slides down the copper pipe, the relative motion between the flux and the copper pipe, the conductor, will create an eddy current that flows around this pipe. So this current, again, is circular. It goes around the pipe, perpendicular to the flux that is cutting through the conductor. Now, anytime we have current flow, we also have what? Anytime we have current flow, we have flux. Because when current flows, all the electrons are going the same direction. All their spin moments add together. So around this eddy current will be a magnetic field. And this magnetic field is opposite to the magnetic field in the permanent magnet. So if this magnetic field is north to south, then this magnetic field will be north to south as shown. So the magnetic field caused by the eddy current opposes the magnetic field that is creating the eddy current. And this is essentially the principle, the phenomena, if you will, that's behind a maglev system. With a maglev system, we move a permanent magnet along a copper rail. That movement of the magnet causes an eddy current in the copper rail. That magnetic field in the eddy, or caused by the eddy current, actually repels the permanent magnet and lifts the car up off the track. So let's take a look. We have a ring magnet here, and the magnet is stuck on the whiteboard, and you can see it. We've sketched in the magnetic flux that exists in and around that permanent magnet. Now, to show that it is not friction that's holding up this magnet, I'm going to drop the magnet down a broomstick. And notice, of course, the magnet flows at 9.8 meters per second squared, minus a slight amount of friction it encounters as it falls along the wooden rod. Now, if I drop the same ring magnet down this copper pipe, note how slowly it moves. Now, it's not the friction of the ring magnet against the side of the copper pipe that's slowing it down. It is what? It is the magnetic field created by the eddy currents that oppose the magnetic field that creates the eddy currents. So as I drop this ring magnet down, notice how slowly it moves. Again, the motion of the magnet creates an eddy current around the pipe. The eddy current around the pipe makes a magnetic field, and that magnetic field opposes the magnetic field in the ring magnet. Now, how cool is that? Now, with Halloween coming up in a couple of weeks, I remember years ago reading an article about how you could take a coil of wire, create an electromagnet, and put it underneath the table, put an aluminum or copper plate inside of a book, and lay that book on top of the table. And when the electromagnet under the table creates a magnetic field, that magnetic field will create an eddy current in the aluminum or copper plate inside the book and actually lifts that book up off the table. So if you want to have a really cool show and tell for your Halloween party, again, all you need is a voltage source, a very strong electromagnet, and an aluminum plate or copper plate to place inside of a book. And you can get all your friends and family to sit around the table and hold hands and cause that book to rise up off the table to scare the dickens out of everyone. So, again, eddy currents, when we have relative motion between flux and a conductor, there's an eddy current created perpendicular to that motion. That eddy current causes magnetic flux. That magnetic flux is opposite to the magnetic flux that creates the eddy current.